So here in this problem, we are provided with a circle. Its equation is given, and here alpha is a parameter that can vary. Now we need to first find out the center and radius of this particular circle. Next, then what we have done is we are going to rotate the circle. Since here it's mentioned that alpha can vary, now let's say alpha changes by some particular angle, and then we have to show that the locus or the part of the new center that we have obtained, that it's also a circle. Now if it is a circle, then we have to find out the center and radius of the new circle that is formed. So let us begin. So we'll start with our initial problem. So in problem, we have given the equation of the circle. So here we have x times cosine alpha plus y times sine alpha minus a whole square added to x times sine alpha minus y times cosine alpha minus b whole square equals to k squared. So this is the equation of the circle that is being provided to us. In the next step, what we'll do, we'll expand the first term as well as the second term. So here we have the form a plus b plus c whole squared. Now when we expand this expansion is going to be of the form a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. Fine. So that means if we have x cosine alpha plus y sine alpha minus a whole squared, then expanding it is going to give us x squared cosine squared alpha plus y squared sine squared alpha plus a squared. Then we have plus 2 times xy cosine alpha times sine alpha. Next we have 2 times the second term and the third term, but we have negative a in the third term, so we're going to get negative 2 ay sine alpha, and then we have 2 times the first term and the third term. Because the third term is negative, we're going to get negative 2ax times cosine alpha. Now coming to the second term, we're going to expand this again using the same formula, a plus b plus c whole squared. So we're going to get plus x squared sine squared alpha plus y squared cosine squared alpha. Actually here we have negative y cosine alpha in the second term, but when we square it, then we're going to get positive y squared cosine squared alpha. Similarly for the third term, we get positive b squared. Now next term will be 2 times the first term times the second term. Since the second term is negative, we're going to get negative 2xy times sine alpha times cosine alpha. Then we have 2 times the second term times the third term, but since both the two terms are negative, we're going to get positive 2 times by times cosine alpha. Then we have negative 2 times the first term times the second term, so we have 2xb sine alpha equals to k squared. Now immediately we can cancel out 2xy cosine alpha sine alpha and negative 2xy sine alpha cosine alpha. What we can do here is we can combine x squared cosine squared alpha and x squared sine squared alpha. So if we take x squared as the common factor, we're going to get x squared multiplied to cosine squared alpha plus sine squared alpha. Similarly, we will combine y squared sine squared alpha and y squared cosine squared alpha by taking y squared as the common factor. So y squared multiplied to sine squared alpha plus cosine squared alpha. Fine. Then we have a squared plus b squared. So we'll come to that later. First, let's try to combine the terms containing x. So we're going to combine this term and this term. So we will take positive 2 as the common factor, and we're going to multiply it to negative a times cosine alpha minus b times sine alpha whole multiplied to x. And then we're going to combine the terms containing y, and we will be taking 2 as the common factor. So we have 2 times, so since we're taking positive 2 as the common factor, so we have negative a sine alpha, and from here we're going to get plus b cosine alpha multiplied to y. Now we will write the constant term, so that will be plus a squared plus b squared, and we're going to transpose k squared from the right hand side to the left hand side. Fine. The whole reason we're writing in this particular fashion, because now what we have is the equation in the general form. Now we know that the general form of a circle is given by x squared plus y squared plus 2gx plus 2fy plus c equals to 0. Now in this general equation, the coordinate of the center, that's given by negative g comma negative f, and the radius r, that's given by the equation r equals to square root of negative g squared, which is simply g squared. So we have g squared plus f squared minus c. Now what we'll do, we'll try to compare the equation that we obtained with the general equation to extract the information regarding g, f and c. Now let's do that. Now on comparing with the general equation, we get 2g will be equals to, so here this is g, so this will be equals to 2 times negative a cosine alpha minus b sine alpha. Fine. So g comes out to be equals to negative times a cosine alpha plus b sine alpha. Next, so 2f will be equals to 2 times negative a sine alpha plus b cosine alpha. Fine. So f will be equals to negative times a sine alpha minus b cosine alpha. And then finally we have the value of c. So c is pretty straightforward. So that is a squared plus b squared minus k squared. So now we have the value of g, we have the value of f. We can define the center and we can also define the radius. Let's first compute the radius. So the radius r will be equals to, so we'll use the formula g squared plus f squared minus c. So g squared will get, so this negative sign will go away. So we have a cosine alpha plus b sine alpha whole squared plus f squared. So f squared, the negative sign again goes away. So we have a sine alpha minus b cosine alpha whole squared minus the value c. So c will then become negative a squared negative b squared plus k squared. So this will be now equals to, so we have going to expand it. So for the first one, we have a plus b whole squared format. So we're going to expand it to get a squared cosine squared alpha plus b squared sine squared alpha plus 2ab cosine alpha times sine alpha. Then expanding the second term, we're going to get a squared sine squared alpha plus b squared cosine squared alpha. But since we have a minus b format, we're going to get negative 2ab sine alpha times cosine alpha. And then we have the remaining terms, so that's negative a squared minus b squared plus k squared. Now here we can clearly see that 2ab cosine alpha sine alpha and negative 2ab sine alpha cosine alpha cancels out. Now further simplification is going to give us, so we're going to take the square root. We're going to combine a squared cosine squared alpha and a squared sine squared alpha by taking a squared as the common factor. So we have a squared times cosine squared alpha plus sine squared alpha plus we are going to combine b squared sine squared alpha plus b squared cosine squared alpha. So we're going to take b squared as the common factor. So we have b squared whole multiplied to sine squared alpha plus cosine squared alpha. And then we have the rest of the terms, negative a squared, negative b squared plus k squared. Now here we're using the fact that cosine squared alpha plus sine squared alpha, that's equals to 1. So we are now left with square root of a squared times 1, so that's simply a squared, plus b squared times 1, so that's also b squared, minus a squared minus b squared plus k squared. So we now have a squared and negative a squared, b squared and negative b squared cancelling out, leaving us with square root of k squared. Now k squared being a perfect square, so we have finally obtained the value of the radius. So the radius of a circle is k. So we will find the radius. Now coming to the center. So the center, which is given by the coordinate negative g comma negative k, so that becomes equals to, I've already defined the value of g, so g is negative of a cosine alpha plus b sine alpha, so but we need negative g, so this will become simply positive a cosine alpha plus b sine alpha. We have a cosine alpha plus b sine alpha. So this is going to be the value of negative g. Then we need the value of negative k. Oh, so this is my bad. This is f. So we need the value of negative f. We have already obtained the value of f. We have already obtained the value of f. So that's negative of a sine alpha minus b cosine alpha. But since we need negative f, it will be simply a cosine alpha minus b a cosine alpha minus b sine alpha. So this is going to be the center of our circle. So we have obtained the information regarding the first part, where we are asked to find out the radius and the center of the circle, whose equation is given by this particular form. Now we have to move on to the second part. Now in the second part, we need to show that the locus or the path of the center of the circle, as alpha varies, is also a circle. That means we're going to change alpha. So if we vary alpha, then we are going to get something else. We have to show that whatever shape we get, whatever geometrical figure we get, it must also be a circle. How do we show that? So now that we have the center of our circle, that's the original circle, what is its x coordinate? Okay, we're doing part 2. The x coordinate, so that's given by a cosine alpha plus b sine alpha. And then we have the y coordinate. So the y coordinate is a cosine alpha minus b sine alpha. Now what we'll do, we'll try to find a relationship between x and xy and ab by eliminating alpha. So let's do that. So what we'll do, let's take this as equation 1 and this as equation number 2. So we're going to take the square of equation 1 and then add it to square of equation number 2. So that means we simply have x squared plus y squared. So this will be equals to a cosine alpha plus b sine alpha whole square plus a cosine alpha minus b sine alpha. The reason why we chose the x and the y coordinate, because what we have done here, this x coordinate, we are getting something which has reliance on alpha. So that means when alpha is going to vary, then x coordinate is also going to vary. So this is the x coordinate of a new circle that we're trying to find. Of a new geometrical figure we are trying to find. We're trying to find out its locus. So let's understand this. So when we expand it, we're going to get a squared plus b squared. So this has been already performed. So we're getting a new equation, x squared plus y squared equals to a squared plus b squared. Now it has no reliance on alpha, but this now has the form, it's the standard form of a circle, which is given by x minus 0 whole squared plus y minus 0 whole squared equals to square root of a squared plus b squared, and then we square it. Now if we compare it with the standard form of the circle, then the standard form is given by x minus h whole squared plus y minus k whole squared equals to r squared. So that means the coordinate of the center of the new circle, which is h comma k, so that comes out to be 0 comma 0, and then the radius r comes out to be square root of a squared plus b squared. Now we were able to tell that this center and radius, which we have used the standard form, that's because using this idea, we have been able to show that the locus of the center is indeed going to trace out a circle, even if alpha is going to vary. So it's not going to be some other geometrical shape, it is still going to be a circle. This proves part 2, and using it we have obtained the center and radius of the new circle. So the center of the new circle is going to be 0 comma 0, and its radius is going to be given by square root of a squared plus b squared.